In this video, we are going to discuss a very popular kind of coding question. This question is asked by many of the coding interviewers, right? And one such kind of question was also asked in Google Kickstart 2020 round A. So the question is workout. Okay, so the problem is that Tambourine, let's call her T. Let's Okay, now read the problem. Make sure you understand the question very thoroughly. Tambourine has prepared a fitness program so that she can become more fit. The program is made of N sessions. During the ith session, T will exercise for MI minutes. The number of minutes she exercises in each session are strictly increasing. Okay, so Tambourine has prepared a fitness program. In each program, she has N sessions, and in each session, she will exercise for MI minutes, right? Also, the number of minutes she will exercise in each session are strictly increasing. Okay, so the difficulty of a fitness program is equal to the maximum difference in the number of minutes between any two consecutive training sessions, right? So the whole difficulty of the program is equal to the maximum difference between any two consecutive training sessions. To make her program less difficult, T has decided to add up to K additional training sessions to her fitness program. She can add these sessions anywhere in her fitness program and exercise any positive integer number of minutes in each of them. After the additional training sessions are added, the number of minutes she exercises in each session must still be strictly increasing, right? Keep this in mind. Now, what do we have to tell in this question is what is the minimum difficulty possible, right? So she has K additional training sessions which she can add to her fitness program such that the difficulty of her program is reduced, right? So we have to tell that what is the minimum difficulty possible. Like if we add any number of training sessions which is less than or equals to K, then what is the minimum difficulty possible we can attain for that program, right? Okay, so let's understand the inputs. So the first input is that we have three sessions initially and she can add up to one more session. So what she has done is she has added a session between 100 and 200 of a value 150 so that the difficulty of a program is 50, right? So reading this input, we can land to a solution that we have to reduce the difficulty of the program. So we'll pick up the maximum difficulty and add a session between that two sessions to break the difficulty into two halves, right? So if we'll check out this, how we can do this is like most of the people would do this. Okay, I'm telling you the most common way which people do, but this way is wrong. I'll tell you why, but understand what generally the coders do. Also, what I did and most of my friends did is like 9, we have 9, 10, 20, 26, and 30. Okay, so this example I have picked it up from here, and she can add up to 6 new sessions. Answer is 3. Let's check out how. So the maximum difficulty right now is of 10 between these two sessions. So we'll add a session 15 of hair like it was done in this example, right? So now the maximum difficulty is of 6, so we'll add another one over here to break it into 3. Now the maximum difficulty is 5, so we can add a program over here. Program can only take integer values, so now it is broken into 2 and 3. Now again the maximum difficulty is of 5, so we can add a So now over here to break it into 2 and 3 again. And now maximum difficulty is a 4 over here. So we can break it into 28. Okay, so I have used 5 sessions till now. I'm still left with 1 session. So the maximum difficulty currently is of 3, right? So I can add a session over here to break it into 2 again of 1 and 2. So now my maximum session difference is of 3 between 17 and 20, 20 and 23, 23 and 26, right? Okay, again I'm repeating, this is the wrong approach. This will give you a wrong answer. I'll tell you why, but this is what most of the people do, is they make a priority queue, they pick up the maximum difference, break it into half, put that back, then again put the maximum tell, pull out the maximum tell now, break it into half, put those two halves back again. So this is going to give a wrong answer. This is not the optimal solution. Okay, we can see it how. So in this method, we are splitting the maximum difference into two halves by adding a session exactly at the midpoint, right? This is not going to give the optimal solution. We cannot perform such direct splits because repeatedly splitting the maximum difference into halves is not optimal, right? If we'll follow this approach, in this example, we are going to break it into 50 by adding a new session of 50, right? And we have 4 sessions with us. Now again the maximum difference is of 50, so I can add a 25 over here. Again the maximum session is of 50, I can add another 25 over here. So I have added 3 new sessions, but I can add 4, so I am still left with 1 session. I can add it over here, right, to break this into 2, but my answer is 25 between this, sorry, it is 75 and this, right? So I have added 4 new sessions at 12, 25, 50 and 75. So but my answer is this. Instead, if we would have done this, that we would have added 4 sessions of 20, 40, 60 and 80. This gives better results. Why? Because over here the answer is 20. Okay, so this gives better results. So this example tells us clearly that what we are doing is dividing a region into two halves does not gives us optimal solution, but dividing a region into multiple equal parts gives us better results. But in this approach, we have to identify how many parts, right? We just have two numbers, but if we would have multiple numbers, then how many parts? So let's think of something else. So, okay, so we want to tell that what is the minimum difficulty possible, right? What can be the minimum difficulty of a program? It can be 1, right? 1 is the minimum difficulty possible. But is it possible? Like 1 is the minimum difficulty of a program, it can be, but is it possible? That means how many additional training sessions do I need to add to make my minimum difficulty 1? If the additional number of sessions, let's say x, is less than or equals to k, then 1 is possible. Else 1 is not possible, right? So we'll check for 2. Then similarly, we'll check for 3, 4, 5 and so on till we reach a point which is possible. So basically we are linearly traversing up to that point. Let me explain you how. Okay, so let's check for all the possible difficulty values of the program and find if it is possible to get that value or not. Minimum difficulty possible is 1 when we add a lot of sessions so that the difference between any two consecutive sessions is 1 and maximum difficulty possible when we do not add any new session, that is difficulty of the original program. So we are going to traverse from 1 to the maximum difficulty possible when we do not add any additional program. Okay, so let's work with that previous example. If we want to check that what is the minimum difficulty possible, let minimum difficulty possible be 1. Then we need to add sessions at 11, 12, 13, 14, 15, 16, 17, 18, 19, 21, 22 till 25, then 27 till 29. So they are total of 17 sessions, right? But we have only 6 with us. So minimum difficulty of 1 is not possible. Let's check for 2. It is 12, 14, 16, 18, 22, 24 and 28. So the minimum number of sessions, or the we will be needing 7 sessions, right? But we only have 6. So let's check for 3. It is 13, 19, 16, 23 and 29. At these points we need to add sessions, right? To this is 5 sessions. So 3 is our answer. Okay. One key observation that you guys need to make is that, let's check for 4, you can do it with 3 sessions. That is, minimum difficulty of the program can be 4 if we use 3 sessions. Minimum difficulty of program is 5 when we'll add a session at 15, right? At 25, 26 won't concern us because the difficulty or the difference over here is 1, but which is less than 5, and over here is 4. So we can do this with 2 sessions. So one key observation is that 3 is a pivot point. No value below 3. Let x be 3. Right? No value below 3 is possible. That is, it is not possible. And from 3, all values will be possible till the maximum difficulty. Okay. So we were linearly searching. We can apply binary search over here. So to find out this pivot point x, right? So binary search would help us. So we can do a binary search with lower bound of 1 and upper bound of m, where m is the difficulty of my original program when I do not add any new session. So let's check the complexity of this approach. So the complexity is O of your m log of m, where n is the size of the array and m is the range on which we are binary searching, right? So this 1 to m is a range. So we are binary searching on this range, so we get a factor of log m, and in each iteration of binary search we will be traversing an array to check if your current difficulty is possible or not, right? So let's code it. So I've already coded, and this is in Java, but the C++ and Python and any language guys would also get it, because we are not using any function. It is a basic int syntax. So okay, so these are the inputs, d, and d is the number of test cases, n is the size of array, and k is the maximum number of new sessions which we can add, right? So these inputs have been taken. Okay, so what is the lower bound of our search? It is 1 because the difficulty, minimum difficulty can be 1. And what is the upper bound of our search? It is the maximum of original program, right? Difficulty of original program. So it is calculated using the max function as described over here, right? And initial answer is R. That is, we do not add any new program, so our answer will be R. Okay, so while lower bound is less than upper bound, the basic classic equation of binary search, we'll go to the midpoint and check if the difficulty of the program is M, how many new sessions do we have to add, right? So we will keep the count of the new sessions which we need to add. Initially my session would be array of 0. So like in this case, when we need the minimum difficulty of the program to be 3. So we are starting with 9, that is array of 0. We'll add 3 to get 12. We'll check, do we need a session at 12? We'll see no, because we have a session at 10 which gives the difference of less than 1. So we would add at 12, we would go at 10. We will add 3 to 10 to check 13. Do we need a session at 13? Yes, because initially your gap is of 10, and if we add a session at 13, gap will be of 3, which is the maximum possible allowed, right? So this is only what we are doing. Initially session is array of 0, and we are checking for the next session, next existing session, that do we need to add a new session between these two sessions. So current session plus n, if it is less than array of I, that is between the current session and the next session, next existing session, the difference is greater than m, so we add a session in between and we'll increase the count, right? Else we won't add a session in between and we'll go for the next existing session, right? So this is a basic thing which we do. And now we have the count of how many sessions do we need, right? We have a count of how many sessions do we need. So if this count is less than k, that if it is possible, then our answer would be m. Our answer will reduce. Initially it was r, we go to m, and we will check for a much smaller answer than m, right? So we will reduce our upper bound to m minus 1. Else we will increase our upper bound, because we know that for all the values less than m, we would be needing of at least p new sessions, but we don't have p, we have only k, where k is less than p. So we will check for more greater values, right? So when this iteration will end, we will print the answer. It is our answer. So let's check if it gives us the right solution. So yes. Okay, so we get a right solution. Yeah, so it was right solution. Okay, so we even cleared the second test case, test set 2 as well, right? Okay, so there are similar kind of questions. You can go and practice them. One is painter's partition problem. You can get this problem on Geeks for Geeks. It is of similar kind. Remember, practice first. You can also read the explanation to get better understanding. Another is aggressive cow on spot, right? You can also practice this question. So yeah, here is the tag is a binary search. So okay, so this is all for this video. If you like this video, please like it and keep coding, keep practicing, keep improving yourself. Thank you so much.